Greetings everyone, today we will learn second chapter basic mathematics. This would be the sixth lecture of this series. Second chapter basic mathematics. Lecture number 6. So in this lecture students we will discuss differentiation, but the second part of it. Basically the formulae and the application part. So let me start with the formulae. Formulae of differentiation. Of differentiation. What is the first formula, students? First formula is y I am taking to be constant. Y such that it is equal to constant. Then dy by dx happens to be d upon dx, and here putting the value of y and it comes out to be 0. This is the first formula of differentiation. Second formula, y is such that c is equal to function of x, then dy dx is what, students? D upon dx, c function of x. So what comes next? C comes out and this becomes, yes, d upon dx and function of x becomes the definition part. And note here where c is a constant. Where c is a constant. Very nice. Okay, students. So the next formula. So in this lecture, students, we will discuss only the formula part and application of differentiation. Third formula, y is xn x raised to the power n, then what? Dy by dx becomes what, students? D upon dx, and this becomes x raised to the power n, this becomes nx n minus 1. Right, students? Definitely, sir. So I would write here where xn is a power function, n is any number is a power function such that y is defined to be function of x. Yes, which happens to be xn here. Okay, students. Yes. The next part, the next formula. Now which formula would come, students? Sir, the trigonometric formula. Yes, definitely. And what others? What others would come, students? Sir, logarithmic? Yes, very nice. Logarithmic would come first. Logarithmic or natural log x. Then what it implies? dy dx d upon dx, and I'm taking natural logarithmic. This gives 1 by x. Okay, students. Yes. Fifth part, y happens to be y is equal to e raised to power x, exponential function raised to power x. So it is inverse of e logarithmic function. So what will happen? I'm talking about the function, not the differentiation part. So it becomes d upon dx. It happens to be ex only. Okay. So this is the thing. Next, now our trigonometric part starts, students. Definitely. Okay. So sixth, y happens to be sin x. What is the differentiation of it? So very easy, cos x. Yes, very nice. Somebody is definitely studying. D sin x cos x. And this is seventh part. Y is equal to cos x. Then it happens to be d upon dx, and this happens to be d dx cos x, and this happens to be minus sin x. Okay, students. So when you differentiate cos x, you get minus sin x. So you have to, when you drive the equation. We are dealing with the formulae part for now. The next part, yes, 10x, very nice. Y happens to be 10x. Then what comes, students? dy dx, d upon dx, 10x. What it is? Sec square x, sir. Very nice. Then ninth, d, oh, sorry, not so fast, sir. Y happens to be sec x. Then what? dy by dx, d dx sec x, and this is what, student? Yes, student, sec x 10x. Okay. Yes, definitely, sir. Next part, tenth. Y is cosec x. Then what, students? dy dx happens to be what? Minus cosec x cot x. Yes, very nice, students. 11th is what? Y happens to be cot x. Okay, students. Then dy by dx is what? This actually gives minus cosec cot x minus cosec square x. Yes, definitely. So these are the basic now product rule. Today I read a quote of Galileo Galilei. He said, mathematics essence lies in its nature to explain universe, and it is God's language. Product rule. Product rule. Product rule. 12th. Y is uv, then dy by dx dx. I am taking y value uv, and this is what, students? Yes, v du by dx, and this is u dv by dx. Okay, students. So you can take any into the first function. Consider v as the first function. Consider u as the first function. So we can do it anywhere. 13, because it is multiplication, students. 13 quotient, but you cannot do in the quotient rule. This the same thing. Quotient rule. Y u upon v. I am taking u as numerator and v denominator. So what could be the solution of this? Sir, ask Sir Isaac Newton. Y du by dx minus u du by dx upon v square. Okay, so this is quotient rule. Next part, chain rule. Chain rule. First part, y is un. So let me define u for you. Yes, it would be substantially good for you. Y is such that it happens to be function of u, and u is a function of x. Okay, so y is such that it happens to be a function of u, which happens to be a function of x. Okay. The next part. So how would you write this into the equation? By hand, sir? Yes, definitely. But dy by dx is happens to be, I would write df by dx, and this happens to be, I should write also the function ux, and here I would not write u, here I would not write f, because I am differentiating the u function now. Okay, so this is the thing, basic thing. So that is, our function becomes dy by dx n un minus 1 du by dx. Okay, students. Yes, sir. Next part, second, what it is? Y is sin u. Then dy by dx is what, students? Cos u du by dx. Okay. Now the next part. What could be the next part? So cos u. Definitely. Cos u. So I believe you are getting the basic nature of differentiation now. Third, y is cos u. This is what, students? So dy by dx minus sin u du by dx. So let me ask, so what are you doing here? I am doing, first, students, I am differentiating this part of the function, then I differentiate this part of the function. Okay, so why such that it has one function within another function. Okay, so I am doing that. Fourth, y is equal to tan u. Of course, tan u would come. Dy by dx, it happens to be sec square, not y, sir. Sec square u du by dx. Okay, next part. What could be the next part? Sir, sec. Very good. But let's stop till here for not going other. It will continue in this. Next part is fifth. Y is happens to be EU. Okay, this is certainly would be EU du by dx. So it is not like EU remains EU. You have to differentiate U also. Okay, so this becomes a little bit different here. Y is natural logarithmic U. So dy by dx is what, students? 1 by u upon du by dx. Yes. Next part. Now you would be saying, sir, this is easy. What if there are two variables, like two numbers within, not not two variables, but numbers with variable. So let me give you an example of what I am saying. Seventh part is such that y is defined to be ax plus b, and this is what, raised to power n. Okay, then dy dx gives us n a ax b n minus 1. Okay, you think of yourself now why I have written this. Okay, because I will drive the last part and it will give the answer to all your formulae. The next part, sin ax plus b. Why is such that sin ax plus b, then dy by dx is what? Cos a cos axb, right students? Then the next part, cos ax plus b. So this is what I will drive. This is what I will drive, and will give answer to both of them. That how this both have come. Why this is the toughest? So I have taken into my account. Why cos ax plus b dy dx. So I will write the whole formula now. Dy by du of chain rule du by dx. This is what the whole formula is, students. Then what should I write, students? Y value d cos u, right students? And d what, students? U value ax plus b, right students? So what came now? Min a. Then here what is students? Sin u, which is what? Minus a sin u. And this becomes minus a. Now putting the value of u. So this is how the answer is coming. Maximum and minimum value. Maximum and minimum value. Maximum and minimum value of a function. So what it is? At points of maxima, and minima. So the points of maxima are those points where the value is becoming maximum of function. Okay students, and minima of course the minimum value of the function. The first order derivative order becomes 0. The first order derivative becomes 0. Not the function, students. The first order derivative becomes, oh, I have not written the derivative part. Yes. Derivative becomes 0. Okay students. So the next part, what should I write now? Completely up to you, sir. So slope is what? Dy dx equal to 0. This is what the statement is, no students? This is equal to 0. The second part, the second derivative proves Proves what, students? Derivative proves slope is positive or negative. Slope is positive or negative. Okay. So you put some value of the first derivative and you get slope has to be positive or negative, or even the function becomes completely positive or negative. So maxima, now I want to discuss maxima part. So you might be wondering, so why the slope is becoming 0 and everything. We are taking it to be equal to 0, and this is actually the physical quantity actually comes out to be positive or negative. Of course, the value exists to be positive or negative, because if it would be 0, then derivative would not exist. Okay, na? So this is the thing. Maximum, maxima. Before maximum, what the value is, students? Means the slope. What the slope is? The slope is positive. The slope is positive. Okay, students. The slope is positive. At maximum, what happens? So this is so easy. It is 0. You have already said. The slope is 0. 0. After maximum. Interesting. Now it will get the slope. What it will happen? The slope is negative, students. Now this is interesting. The slope is negative. Why the slope is negative? I ask, why the slope is negative? Actually, the curve is becoming negative. So that is why the slope is coming out to be negative, students. The value is constantly increasing. So it is reaching its maximum value possible. So I would write mathematically dy by dx happens to be 0. And this is what I mean by this. This is negative. Okay, students. This is negative coming out of it. This is 2 and this is yes. The next part, minimum. What the minima is? So minima before maximum, the slope is positive or negative. It can be both. Okay. So in this case, at, but in maximum case it is negative. At minimum, of course, the slope is 0. After minimum, after minimum it is what, students? Sir, it is positive. After minimum the slope is positive. Okay, mathematically what would I write? Mathematically, not here, sir. Mathematically I would write dy dx, this happens to be yes 0, and this happens to be dy dx cube, this is yes positive. So I will stop here for now. Thank you.